Okay, so in the first video we were talking about the trigonometric ratio. So let's just go back to it. So we know that sine of any angle theta is equal to the opposite over the hypotenuse, okay? Cosine of any angle is equal to the adjacent side, ADG for short, EDJ, over the hypotenuse, and then the tangent, which does not care about hypotenuse, tangent theta, is equal to the opposite over the hypotenuse, okay? So there's essentially two levels of problems involving solving for length, and then we have the three ratios that we can use. So let's do an example here, okay? I have a right angle triangle with my right angle. So automatically I know this is my hypotenuse because the right angle is pointing at my hypotenuse. And my hypotenuse is always my longest side, okay? So let's say that I know this angle, and so level one is when we know the hypotenuse. So say I know the hypotenuse is 10, okay? And I say, for example, figure out what this side is, okay? If that's x, and then this is y, okay? So I look at this and I say, okay, well, if I'm solving for x, I want to figure out what the length of x is. Well, what do I know here? Well, I know that x is the opposite side to my hypotenuse, and I do know the size of my hypotenuse. So I look at my ratios. I look which ones have opposite and hypotenuse in them, and it's the first one there. So what I do, and I'll say that this angle is, for example, I'll have to know that it's 35 degrees, for example, okay? So I go, the process is I say, okay, well then, sine of 35 is equal to my opposite, which is x, over 10, which is my hypotenuse. And now I just have to solve for x. So how do I solve for x? Well, first I want to get rid of this 10 down here. So the opposite of something being divided by 10 is multiplying by 10. So I multiply by 10 here, these go away, and then what I do to one side of the equal sign, I have to do the other. So now it's 10 on this side, 10 times. So that simply means that x is equal to 10 sine of 35. Now I can use my graphing calculator to solve for that. First I need to know, I have to go into mode. I don't know if you can see this, but I have to make sure in mode that I'm on degree. I'm in degrees. I don't even know if you can see that. It has to be in degrees, okay? And I'll just type that in. I'll go 10. I don't even have to write multiply. I can just write sine, and then in the bracket 35, close the bracket, and then that gives me an answer of 5.7357. So I'll just say 5.7. So x is equal to 5.7. I've done it. That was pretty easy. And now say I wanted to solve for y here. Okay, I could use, now that I've figured out x, I could use Pythagorean theorem, but let's do it using our trigonometry. So say I didn't know this yet. I'm making a video here. I'll come talk to you in just a second, okay? So cos of this 35, well, so I know this adjacent side to 35, and I know my hypotenuse. So adjacent is touching the angle, and there's my hypotenuse. So I look, which one has adjacent and hypotenuse? Cos does. So I go, cos of my angle 35 is equal to the adjacent, so y over 10, which is my hypotenuse. And I do the exact same thing here. So I want to get y alone. I want to solve for y. So I multiply by 10 to get that 10 out of there. And then what I do to one side of the equal sign, I do to the other. And then now y is equal to 10 cos of 35. And I put that into my calculator, and so 10 cos 35, and it gives me 8.2. I have figured out what x is, and I have figured out what y is. Pretty darn easy. Now say, for example, they told me what this side was. They said this side is 10, and then this side is x, okay? And they're like, solve for x. Well, now I don't know what the hypotenuse is, but I know that I have an opposite side that I'm trying to solve for, and I know the adjacent side. So I look, what has an opposite and an adjacent in it? 10. So I would go tan of 35 is equal to x divided by 10. And then I would do the exact same thing, times 10. 10 times 10 here. And x would be equal to 10 tan 35. X is equal to 10 times 10, 35 is 7.0, okay? So this is how we use the different trigonometric ratios. Now, for these examples, my unknown was on the top. So my unknown in this case was the opposite side, the adjacent side, and then the opposite side. What happens if it was the hypotenuse here was my unknown? And here again. Well, let's see what that would look like. It just means the math, there's like one additional step in the math, that's all. And it's pretty straightforward. So let's go back to the so say I did not know my hypotenuse. That was actually my unknown that I wanted to solve for. But I knew that this was 5, okay? So I would look and I'd be like, okay, I want an equation that's got hypotenuse and an opposite side in it to my angle, because this is opposite. So again, I'd go, okay, it's sine. So I would write sine, in this case, 35, is equal to my opposite 5 divided by x. Now I have to solve for x. So how would I do that? Well, first I want to get x out of the bottom there. So I'm going to multiply it by x to get it out of there. And what I do to one side, I do to the other. Now I have x times sine 35 is equal to 5. And I want x to be alone. I want x to be alone on the one side. So I have to get rid of that sine 35. Well, how do I do that? Pretty easily. I just divide by sine 35. And what I do to one side, I do to the other. And so x now is equal to 5 over sine 35. And I put that into my calculator, and I get an answer. 5 divided by sine 35. It gives me 8.7. Great. Okay? And same thing. Say I knew that this was 7, and I wanted to solve for my hypotenuse. Well, again, I'd say, okay, so I know my adjacent side. I know my hypotenuse. So I'm going to use my adjacent hypotenuse, so cos. So I do the exact same thing. Cos 35 is equal to adjacent 7 divided by x. Now I want to get the x out of there, so what I do to one side, I do to the other. And then I have to isolate for x now. So I want to get rid of this cos 35, so I divide it out, because the opposite of being multiplied by something is dividing it out. And then this becomes cos 35. And then x is equal to 7 divided by cos 35, which gives me an answer of 7 divided by cos 35, 8.54. And the same thing would happen in the tan, okay? So if, say, this is my x, and I knew this was 8. Well, it's going to play out the exact same way. This time it's just tan. So tan of 35 is equal to my opposite, 8 divided by x. And I'm going to go through the same steps. Multiply by x, and x is going to equal 8 over tan 35. This is solving for unknown sides. Every question you see solving for an unknown side is going to be one of these 6 situations. It's either going to be sine, where you have your unknown as your opposite, or it's going to be sine, where your unknown is your hypotenuse, or it's going to be cos, where your unknown is your hypotenuse, or cos, where your unknown is your opposite, or tan, those two. So really 6 different problems when using trigonometry to solve for length in a right angle triangle. The next level, which we're going to talk about in the next video, is now just solving for an unknown angle. So
we'll talk about that in the next video.